terms, I factored it out next to the r. Do not be nervous about that factor that's up front, because I'm being instructed that x is strictly positive. So I do have the mathematical legal right to cancel the x to the r. I can divide both sides by it. It's non-zero. Oh no, that means I've got a math D question. Guys, I'm tired. I don't want to do any work. So help me clean this up. I'm tired. I don't want to do any work. Maybe take a peek at this grouping. Pull out an r minus 1. Identify what the heck remains standing above the brace when I pull out an r minus 1. I think it'll be this. It's just that from the last grouping, if I pull out a minus 2, oh shoot, look at that. I see a nice pretty factor of r minus 1 again. Being lazy in my usual fashion, I will now take these two terms and pull out the common factor of r minus 1 and see what the heck remains standing. I think that's going to give me an r squared. Is that minus 2r plus r, which is minus 1r? Oh, there's my minus 2. Well, with that trinomial, I can factor even further. I've got my r minus 1 times r minus 2 times r plus 1. But like I said to you guys, this is a math question. So I suggested what this really tells me is that I've got 3 linearly independent solutions. The first one is x to the first r value. The second one is x to the second r value, which is positive 2. And the third one is x to the third r value, which is negative 1. Shoot, you know what? I don't think I answered the question. Determine the general solution of this differential equation. I didn't. So to answer the question directly, I will state that the general solution is a linear combination of these three. I think that's what my solutions look like. So just double check me, see if the author agrees in the back of the book. He does. Oh, Bradley, you said you want to answer that one question. So you guys, do you think I can be official today? Officially, I want to take a peek at solving this differential equation, if I can erase a tad bit. So in question number 35, I am asked to consider this DE. So you guys, I would have supposed that I've got a solution to a homogeneous DE. I'll call it y sub c. Actually, I really like the letter c, so from now on, you guys, if I'm going to solve a differential equation and I come up with all solutions to a homogeneous one, I might refer to those solutions as a complementary solution. As opposed to a particular solution to a DE, that is to say, a particular solution to a non-homogeneous DE. Now, I have to confess, since y sub p satisfy this differential equation, then when I actually subtract f of x from both sides, I'm seeing that the sum of these two b's is necessarily going to be all solutions to my differential equation. I think all solutions to the non-homogeneous DE are merely going to be nothing more than the sum of my complementary solution with a single particular solution to the non-homogeneous case.
Do you remember which question number this was?
Yes, number 18.
Number 18,
I just be really
6.2?
slow in getting to
Okay.
it, if you don't mind. Bradley, I made a mistake. It's number 35.
Oh, number 35, all right.
Yeah.
Okay, yeah, that's what I'm at.
Will any particular solution work?
Yes.
And they will all be the same set.
Say that again.
If you take any particular solution and you add it to your complementary solution, and they'll produce the same set as using another particular solution. If any particular solution is valid.
It will generate the same, in the end, it'll generate the same collection of functions. The reason why I'm stalling is that this complementary solution looks like this. Then I think this is an alternative complementary solution. I'm being silly. But I want to answer your question truthfully. In other words, throwing in coefficients, I know makes these individual functions here and here different than what I had before. It's just that all linear combinations of these two beasts are going to generate the same collection of functions as the linear combination of these two beasts in the end. Because C1 and C2 are going to range over the entire rails. But I confess, your particular solution, it will be very specific. It will be one solution. It's not as you're going to get, oh, a lot of choices for y sub 2. So taking a peek at number 35, I have this differential equation. Oh, it's on the board.
Is it?
You guys, can I give you a title for this? Even though I'm looking at an exercise. I'm sorry for the short title. So using my method of undetermined coefficients for non-homogeneous linear nth order differential equation, I give up, it's too hard. And
Wait.
instead, I look at the homogeneous case. And in looking at the
I don't
homogeneous
think
case.
that is 35 up there.
Oh, did I make a mistake?
In 6.2, 35?
My apologies, I'm in 6.1.
Oh yeah, 6.2, 35.
Oh, shoot. But number 35 and 6.2 is so easy.
Oh.
You guys don't erase this. I want to come back because this is going to start my lecture today. But meanwhile, Brad doesn't want me to take a break.
Oh, it's all right. You can go to 6.1, 35.
Well,
I was
just tell me then what I'm going to do in number 35. The other section.
I'm not entirely sure. That was the one that Michael asked.
Oh, it
Yeah.
solved the given initial value problem, and I was curious on how that actually
Yeah.
start that problem.
Oh, it's this easy. Watch. I'm going to list for you on import, not the DE, but I'm going to write down the characteristic equation. And I think the characteristic equation looks like this. And I think if you can solve this characteristic equation, you solve the DE. No, I think if you solve this characteristic equation, you solve the DE. You know, solve this equation. Rational root theorem. So I think if this equation has a rational zero, it's going to be of the form P over Q, where P divides evenly into the constant term. That means I've got these choices. You guys, am I talking too fast?
Can you just back by grouping?
I just tried. Oh my goodness, did it really work?
Yeah, you can on that one.
I am
Look at
very
that, yeah.
unhappy. When I glanced at it, I tried it, it didn't work. Never mind, that wasn't much fun. Does he ask you any other non-simple questions? Are they all that basic?
Rational root theorem part 2 plus 2 times r is 1 is 2 squared.
That is a pits. Even number 27, sheepers. Okay, you guys understand that the Homer set is simplistic, right? Okay. Just letting you know. So can we skip it since it's so easy? That really is a mathy question. And if that is okay, let me come back and let me take a peek at the homogeneous case. And when I say take a peek at the homogeneous case, I mean let's see when I take a peek at solving this differential equation. Now, in solving this differential equation, I think since it's homogeneous, life's a piece of cake. All you and I are going to do is take a peek at the characteristic equation, which we can solve in our sleep. I hope. And therefore state that the solutions are going to be. Did I make a mistake?
It should be positive 3 negative 3.
Should it?
Oh, okay. No? Then you're gonna set equal to 0. That's right.
You guys just double check what math you do.
And the first R equals is that.
If I factor, I get an R plus 3.
Yeah.
But then equals 0, I get R equals negative 3. So I think my complementary solution looks like a C1 e to the negative 3x plus C2 times e to the 2x. Wow, you guys, that was fast. The homogeneous case is a piece of cake. We had some practice with that last time. I think when it comes to the non-homogeneous case, it's not a piece of cake. So in the non-homogeneous case, here's what I'm going to do. I got my two eyes, and they're floating. They're not the same level. One eyeball's got an eye on the particular components of the complementary solution. My other eye is looking at the forcing function. Now, I want a yes or no answer. With what's in here, underlying in here, with the forcing function, is it linearly independent from these two seeds?
Yes.
Absolutely. And so I'm going to try to generate what I refer to as a particular trial solution. And I think it's going to have to match up exactly with what the forcing function looks like. I think it's going to have to be e to the 3x times I don't know, something, I'll call it a. Now I refer to this as a method of undetermined coefficient because I think the value of that constant a is undetermined, and it's a coefficient. I need to find the value for a. But since I'm assuming my solution looks like this, which by the way is a safe assumption, because when I differentiate repeatedly, what you get on the left-hand side is going to have to be equal to something involving e to the 3x. Then I'll differentiate repeatedly and substitute back in my e. And if I were to differentiate once, and twice, and then substitute back into my original non-homogeneous DE, I think on the left-hand side, I've got my y double prime plus my y prime minus my 6 times y being equal to nothing more than my 18 e to the 3x. Oh, the heck with it, you guys. Both sides have a common factor of e to the 3x. It's never equal to 0. I'll divide out by it. And I think that leaves me with a total of, is that a 6a being equal to 18? Well, I found the value of the undetermined coefficient. That being the case, I will state that all solutions, even to the non-homogeneous DE, are going to be of the form of the sum of the complementary solution and one particular solution. And so I think all solutions to my DE are going to look like nothing more than a C1 e to the negative 3x plus C2 e to the positive 2x, specifically plus 3 times e to the 3x. Now, I gotta confess, if I'm given some initial value conditions, I can actually go ahead and solve specifically for C1 and C2 in that particular case. Do you guys mind if I don't do that? That's just a bit of arithmetic. Michael?
The one thing I was noticing from this problem, I noticed that the relation of setting y equal to e to the rx, it seems to be like that's an important. I don't know if it's a substitution or.
Wasn't that actually the whole thing I based the last of the lecture on? That's the way I generated how you and I can list all the solutions to the homogeneous DEs, given special looking sides on the left, where I've got constant coefficients. And so when I assume my solutions are the form y equals e to the rx. It allowed me to generate that characteristic equation, at least in the homogeneous case. So yes, it's fundamentally important. Everything I said yesterday is based on just that one substitution. Daniel?
So, looking at the later questions of 6.1 that have the x cubed, x squared, and we just made the assumption that the answer is going to be the form x to the r, are we just going to be learning new patterns that are going to have results that look
Or how about saying this, just new methods of solving DEs. When you take a peek at my DEs so far, yesterday and today, where I've got constant coefficients, I think e to the rx is an easy approach. But when you have those factors x, x squared, x cubed walking backwards, those are not constant coefficients. Then I think when you look at a substitution of y being equal to x to the r is really nice, because each and every one of those terms have all their exponents being added to r. And assuming an x is strictly positive, I can divide both sides by the x to the r. It was just an alternative technique and an alternative type of differential equation with non-constant coefficients. Definitely. You guys, shoot, my example's too, it's too, it really is. It is. Would you guys agree that in a homogeneous case, life is a 100% absolute piece of cake? Can we apply the French technique? So, relative to what we discussed yesterday in class, do you guys think you can give me the comprehensive solution? Oh, really? C1. I can't hear you.
X.
Well, X will work, okay. Plus. I feel so alone.
So, how do you decide when it's going to be an e and when it's going to be an x? That's what I'm a little unsure of.
Oh, that hurt.
I know.
I think if in that characteristic equation I've got two real solutions,
Okay.
I think my general solution is going to look like this.
And so if you only have one, then it's just an x
That if I
raised to
only
that
have
power?
one real solution to the characteristic equation, I think my general solution is going to look like this. And I think if I have two complex non-real solutions, then I think my complementary solution is going to look like, do you guys remember? E to the alpha x times C1 cosine beta x plus C2 sine beta x. Do you guys remember all that business? It took me, I have to confess, it took me all day yesterday to
I know.
prove to you that this had to be the case.
Can you leave that up?
Yes.
All right.
So I think in this example
So-
over here, notice that I've got a duplicity of this particular real zero to that characteristic equation, and therefore I think my solutions are going to look like C1x plus C2 times e to the 2x.
Wouldn't it be c1 plus c2x?
Well, that's the way I wrote it there. It's just that Chris was writing off the solutions. I just wrote it the way he was saying it. Same thing, isn't it?
Is it?
Well, yeah. It's just a constant
Okay.
plus a constant times x as a
Okay.
factor. And look at this. I got a constant plus a constant times x.
Okay.
And I think in the non-homogeneous case, here's what's happening. I got two floating eyes. And I think one eye is looking at that forcing function and trying to create the most general type of forcing function I have over there. And I think that forcing function has an exponential factor and a linear factor. And I think the most general form of that particular solution then is going to be something like an ax plus b times e to the 2x. Now, what I'd really like to do today in class is really be instructive if I had the time. And if I had the time, I'd waste it by trying to find a's and b's. And you would see that I can't generate them. The reason why I can't generate them is because aren't these already the components of your complement solution? That means naturally, if I were to pick this beast up off the ink board, slap it in for y here, here, and here, I would get a 0, not an x e to the 2x. Because it's already a complement solution. So what I'm going to do is I'm going to use my hands to remove duplicity. Remember, I got one I on the forcing function, one I on my complementary solution, and I think I duplicate once what I see in my complementary solution and duplicate twice in my complementary solution. So to remove that duplicity, I will introduce an extra factor of x squared. Well, just like I introduced another factor of x over here, didn't I? When I was looking for two solutions that were linearly independent. Same idea.
It's so arbitrary.
Well, I think it's quite not arbitrary. And specifically rooted in the duplicity that I saw down here.
Why x squared in particular?
Because if I only do an x, shoot, there's a bx term. Oh, shoot, that's still part of my complement solution.
Why not x cubed? Because it's less simple than x squared.
Definitely not simple.
Yeah.
You guys, it looks too awful. Can I rewrite? I suppose what I really have is an ax cubed plus bx squared times my e to the 2x. I got a bit of work to do. Because now when I differentiate once, I've got the first as is, times the derivative of the second, plus the derivative of the first, times the second as is. Oh shoot, it's too much of a mess. Can I clean that up a little bit? I think what I'm really suggesting is that I have, is that an ax cubed plus, oh, I missed my 2 up front, hold it. I meant to say 2ax cubed. Plus 2bx squared and a 3ax squared. That'll give me a 3a plus 2b times x squared. And finally, as far as my x term is concerned, I guess I've got a positive 2b times x, all of which is being raised to e to the 2x, or being multiplied, excuse me, to e to the 2x. Oh shoot, you guys, I got a bit of work to do. I've got to differentiate again. And so in differentiating again, I think that's going to give me my second derivative for y sub p of x to be nothing more than the first. You guys, I took my glasses off, so just make sure I'm writing down the right numbers. Instead of 3a plus 2b times x squared, and finally 2bx, all times e to the 2x. Well, chain rule says multiply by. So 2. Plus, this times the derivative of the first, but the derivative of the first is simply going to give me a 6ax squared plus a 6a plus 4b times x plus a 2b. And all this is being multiplied to e to the 2x. And if you guys allow me to come in and simply pull out the e to the 2x, let's see what's left over. As far as the x cubed terms are concerned, I've only got one of them. Does that give me a coefficient of positive 4a? Let's next talk about the coefficients of x squared and the coefficients of x, and maybe even the constant terms, all of which has an e to the 2x being pulled down. Did you guys see there's quite a bit of bookkeeping? I haven't even substituted my original DE yet. Well, collecting all my x squared terms in terms of coefficients, you guys, here's one. And, oh, that's not bad. Here's the other. I think that merely gives me a 6a plus 6a, which gives me a 12a as one of the coefficients for x squared. The other one's merely going to be a 4b. As far as the coefficients of x are concerned, that would be above this squiggly line and above this squiggly line. You guys help me with this. Is that going to be a 6a plus, is that an 8b? You're not going to help. And then finally, for my constant terms, that's just a 2b.
Then you just need an x.
Oh, do I? I missed the x? Thank you very much. It's my placeholder. And I maintain, if you take a peek at these three circled red beasts, this one, and this one over here, pick them up off the ink board, slap it in for y, y prime, y double prime, here's what I'm gonna get. So substituting. Into the non-homogeneous DE. I guess it's going to give me my second derivative. Minus 4 times the first derivative. Uh-oh, I'm in trouble. I'm too far away. I said minus 4 times the second derivative, but that's just going to give me, is that a minus 8ax cubed? Plus a negative 12a minus 8b times x squared minus an 8bx plus 4 times the original function y, but that's just simply going to give me a 4ax cubed. Is that a plus 4bx squared? You guys, did I forget anything?
Yeah, it's equal to equals
Well, not only that, but I think with each and every one of these groupings, I forgot a factor of
e to the 2x.
e to the 2x. I'll put it in. So I guess I get all this garbage on the left-hand side times my e to the 2x being equal to, I cannot possibly remember,
It's either x
x e to 2x. Well, you guys, if you don't mind, can I just cut to the chase? Can I just cancel it? It's never equal to 0, so it's perfectly legal. However, when I come in and try to equate coefficients, something really nice is happening. You guys, I don't need any more board space. I think we're done. Because I think when I come in and combine all the x cubed terms, oh, thank goodness they cancel. They better. I don't have any x cubed terms on the left-hand side. Excuse me, on the right-hand side. As far as the x squared terms are concerned, oh, check this out. Look, complete cancellation. They're gone. I think I'm merely left with a very, very tiny math B question, which is, in equating coefficients of x to both sides of my equal sign, and equating constant terms to each side, I think that tells me that 6a plus 8b is equal to 1. And I think it says that 2b is equal to 0. But that implies b is equal to 0. Whereas it implies that a is equal to 1/6. I'm sorry, I went through all that work just to get one fraction 1/6. But at least, y'all wait.
You have 6a plus 8b, you also have a negative 8bx. So it'd just be 6a equals 1.
My apologies, I didn't catch that. Thank you. I think when I combined these two squiggly line terms, I didn't see that I had another x term down there. Okay, that changes things a little bit. That means I've got 6a being equal to 1.
I guess
Oh,
it's
pure
the same
coincidence. It didn't make any difference. And I think I can state my final answer, if I can possibly remember it. So I think my final answer is going to be that all solutions are going to be my complementary solution plus my particular solution, which has us my b being equal to 0, but my a being equal to 1/6. We got it. Chris.
Shouldn't it be 1/6 x cubed?
It is, so I've got my 1/6 times x cubed. What did I write? Ay, ay, ay. I appreciate it. I got a little lucky with the b being 0, by the way.
I forgot, so when would you have for the x squared?
If I've got duplication with what you see over here in the complementary solution, that means I've got to remove that duplicity. And I had to do it twice because I had two things matching up. Because when I first came in here, I said, let's consider that as my trial particular solution. And I think that's wrong simply because I think both these terms duplicate what I have in here. So I tried to introduce a factor of x to remove the duplicity, and I failed. Because here's a bx times e to the 2x term, I've already gone with it. So I had to multiply by an additional factor x to remove that duplicity. Okay?
I missed why you chose to initially start off with that ax plus b.
Here's what I was thinking. I was trying to find the most general form of the forcing function. That's how I make a decision initially on what I put in the trial particular solution's place. Notice how there's a linear factor times this exponential factor. So I wrote down the most general linear factor times that exponential factor. Now I can't do this with every forcing function. It's going to be fairly limited. So I have to develop some other techniques of solving ease when my forcing function isn't that beautifully clean. You guys, I feel like I only gave you 2 examples. Can we just take a break from the homework?
Yeah,
Let me get more examples tomorrow.
so I'm a little confused here. When you find your forcing function, basically, or when you added the x squared, is that different per case? I mean, do you just have to kind of strategically figure out what that's going to be?
What you're going to do is you're going to keep introducing an extra factor x,
Okay.
so that what you see over here is not duplicated anywhere in there.
So, okay.
So, Mr. Dogger, I forgot all that